Hello, friends. Welcome back. We're finished with Unit 9. We're finished talking about factoring quadratic expressions. But keep that in the back of your brain because we're going to be using that in the upcoming units. The next two units are all continuing to be about quadratic functions, quadratic expressions. Specifically in this unit, Unit 10, we're going to talk about solving quadratics, solving quadratic functions. So in the past, you have seen functions or equations like this, like 2x equals x plus 3, or x divided by 6 equals 14, or 3x plus 8 equals 12. You've seen equations like this. These are linear functions. You can solve these pretty straightforwardly. Most of you feel pretty comfortable with equations like this. You get x all by itself on one side, get all your numbers on one side by themselves. You solve for x, you get one answer, you're set, you're good. So now, we're talking about, those were linear functions, now we're talking about quadratic functions. Remind yourself for a moment, what is a quadratic function? Well, if you remember back to Unit 8 when we talked about different types of functions, a quadratic function is one where the variable x is squared. And it looked like this kind of U shape. We called this sometimes a parabola or a quadratic function. So a quadratic function is denoted by the x squared, and it's denoted by this U shape, either an upside down U shape or a regular U shape like that. That's what a quadratic function is. So that's what we're talking about. We're talking about those types of functions, how to solve those quadratic functions. So that's what this whole unit is about, different types of quadratic functions that we see and how to solve them. We're going to start this unit off, Concept 1, solving quadratics by square root. What does that mean? We will see. So by the end of this lesson, I hope that you are able to solve a quadratic equation using the square root method. Hopefully you understand what a square root is. We'll use that in this lesson here today. So before we get too far into solving quadratics, let me show you here that every quadratic equation has two solutions. It has two answers. And those two answers will come in one of three forms. Either you will get one real solution repeated twice. That's the first option. So let me give you the example of x squared equals 0. What value could I put in for x to get x squared to be equal to 0? Well, 0 squared is 0. And that's it. There's only one possible answer. One real solution, 0, that would make that quadratic function true. So the solution to this quadratic function, I solved it, the answer is x equals 0. The other option that we might have is we'll have two real solutions. So take a gander here. If I have x squared equals 9, what do I need to put in for x that would make x squared equals 9? Well, 3 squared equals 9. That's a no-brainer. 3 times 3 is 9. But also, negative 3 squared equals 9. Because negative 3 times negative 3 is a positive 9. So those are two solutions. X equals 3, and x equals negative 3. Two real numbers that are solutions. Up here, x was equal to 0. Down here, the last option that we could potentially see is two complex or imaginary solutions. So if I have x squared is equal to negative 4, what number would I put in for x to give me a negative? Well, if you remember back to the first try of Math 2 when we were talking about imaginary numbers, when I square an imaginary number, I get a negative number. So right here, if I were to take 2i squared, that would give me negative 4, or it would give me 4i squared, or in other words, negative 4. Also, if I were to take negative 2i squared, negative 2 times negative 2 is a positive 4. I times I is I squared. I squared is equal to negative 1. So my solutions here would be 2i and negative 2i. Two complex solutions, or two imaginary solutions. Don't stress super crazy hard about these right now. We're going to see more of them in the upcoming units, but know that these are the three different types of solutions that you can get. Also, I'm going to show you what their graphs would kind of look like. Again, we explored these graphs a little bit more in our next unit, but I want to bring it up for you as to this is what it would look like. If I had a quadratic function, the quadratic function, the parabola that has one real solution would look like this. It would touch the x-axis in one place. A quadratic function that had two real solutions would touch the x-axis in two places, two real solutions. A quadratic function that has two complex or imaginary solutions would not touch the x-axis at all. So you'll see that this will become helpful in the upcoming units. I want to point that out. But keep in mind that these are the three different types of solution sets you will see with quadratic functions. Okay, into the meat and potatoes. To solve an equation using the square root method, treat the equation as if it were linear and isolate the variable by itself. In other words, get the x squared term by itself and get everything else on the other side of the equal sign. Then we'll square root both sides. So let's do that right now. Notice in each of these, in our last unit when we were talking about factoring quadratics, we had quadratics of the form ax squared plus bx plus c. Notice here, I don't have an x term. I don't have a b value here. I just have x squared minus 81. When there's not an x term here, that's when I can use the square root method. So for example, I have x squared minus 81. I'm going to get my x squared on one side and everything else on the other side. So I'm going to add 81 on both sides and get x squared equals 81. Well, now I'm going to get x by itself by square rooting both sides, because x squared square rooted is just x, and the square root of 81 is 9 or negative 9. So I have two solutions. Again, there will always be two solutions, either one real solution repeated, two real solutions, or two complex solutions. So my solutions here, my answers are 9 and negative 9. And notice, if I were to plug 9 or negative 9 back into x here, that would satisfy my equation. 9 squared is 81, minus 81 is 0. Negative 9 squared minus 81 is indeed 0. Okay, let's do this one. X squared plus 64 equals 0. So I'm going to minus 64 on both sides. I'm going to get x squared equals negative 64. Okay, well, I'm going to square root both sides. I'm going to get x equals, this is a negative number underneath the square root, so the answer is going to be imaginary. Other than that, the square root of 64, you can just type right there in your calculator. The square root of 64 is 8. So my answers are either 8i or negative 8i. 8i or negative 8i. Notice here I had two real solutions. Here I have two imaginary or complex solutions. And notice again, I have 9 and negative 9, 8i and negative 8i. With these, that's how it's basically going to be across the board. We'll see this as we continue to go along. But that's how I solve these types of equations. I get my x squared term on one side, everything else on the other side, square root both sides. Okay, let's do a couple where there's a few extra steps. So here I have 2x squared minus 64 equals 0. Well, I have 2 times x squared minus 64. I need to start undoing this equation by taking care of everything that's the farthest away from x squared and then working in. So I need to add 64 on both sides. So you get 2x squared equals 64. Well, x squared isn't completely by itself yet. It's still being multiplied by 2. So I need to divide by 2 on both sides. So I get x squared equals 32. Well, now I can square root both sides. The square root of 32, I just typed that on my calculator, I'm going to write it as a decimal, is 5.66. But it will also be negative 5.66. Okay? Whoops, that was bad. My answers are 5.66 and negative 5.66. And if I were to go back here and put 5.66 or negative 5.66 in for x again, 2 times, let's do 5.66 squared times 2 minus 64, indeed, is going to be 0. Okay, let's do this one right here. I'm going to subtract 81 on both sides first. I have 3x squared plus 81 equals 0. I need to get rid of this plus 81. So I have 3x squared equals negative 81. Then I'm going to divide by 3. I get x squared equals negative 27. Then I need to square root both sides. The square root of 27, the square root of negative 27, is going to be 5.196i. Whenever I take the square root of a negative number, I basically just square root the regular number and put an I at the end. 5.196i and negative 5.196i. Those are my two solutions. Notice here I had two real solutions. Here I had two imaginary solutions. Okay, remember, every single quadratic will have two solutions, two answers every single time. Okay, let's look at a couple other types of questions. Let's see what we have here. Okay, these are set up a little bit differently, but we're going to follow the same pattern. So I have x minus 1 squared minus 9. I'm going to start farthest away from the x and take care of that first. So I'm going to add 9 on both sides and get x minus 1 squared equals 9. Okay, well now the farthest thing away from x is this squared. I'm going to have to take care of the squared part before I do anything in here. So let's square root both sides. I have the squared, all this in the parentheses squared. I'm going to square root both sides. I'm going to write something here, and I'll show you why in a minute. So I'm going to have x minus 1, because this cancels, equals 3. But also, I have x minus 1 equals negative 3. So when I square root both sides, the square root and the square cancel each other out. The square root of 9 is either 3 or negative 3. Because 3 times 3 is 9, and negative 3 times negative 3 is also 9. Okay, so now I have two different equations that I'm going to try and solve here. I have x minus 1 equals 3, so I'm going to add 1 to both sides and get x equals 4. Then here I have x minus 1 equals negative 3, so I'm going to add 1 on both sides and get x equals negative 2. See what I did there? See what we're doing? So my two solutions are negative 2 and 4. Those are my two answers. Let's double check that we're not crazy. Let's plug those back in. So if I do negative 2 minus 1 squared minus 9, what do I get? Well, negative 2 minus 1, that's negative 3. Negative 3 squared, negative 3 times negative 3 is 9. Minus 9 is 0. Perfect. Golden. Love it. Okay. What about my other solution? What about 4? What if I do 4 minus 1 squared minus 9? Well, 4 minus 1 is 3. 3 squared is 9. 9 minus 9 is 0. So yeah, there are two solutions to this problem, negative 2 and positive 4. Okay, let's do one more. Let's do this one right here. So again, I have 4. So now I have 4 times x plus 3, parentheses, squared, minus 16 equals 0. So I'm going to start as far away from here as I can. I'm going to add 16 on both sides. I kind of start with my addition and subtraction, go backwards. Okay, so I have 4 times x plus 3, parentheses, squared, equals 16. Well, my squared stuff, this parentheses, isn't by itself yet. It's being multiplied by 4. So I have to divide by 4 on both sides. So I get x plus 3 squared equals 4. 16 divided by 4 is 4. Okay, now I have this whole squared nonsense all by itself. So now I can square root both sides. And I'll have x plus 3 equals 2. And I will also have x plus 3 equals negative 2. Because the square root of 4 is 2, as well as the square root of 4 is negative 2. Negative 2 times negative 2 is positive 4. 2 times 2 is positive 4. So let's solve both of these equations for x. Now it's easy money. x plus 3 equals 2. I'm going to subtract 3 on both sides and get x equals negative 1. Here I have x plus 3 equals negative 2. I'm going to subtract 3 on both sides and get x equals negative 5. So my solutions are x equals negative 5 and negative 1. Remember, I will always have two solutions with a quadratic. Two solutions. Two real solutions, two complex solutions, or one solution repeated twice. And if I were, and you can double check this by yourself, if I were to plug negative 5 back in for x and negative 1 back in for x and evaluate that side of the equation, I would indeed get 0. Okay, let's go through a real-world type problem. I love this problem because you might have seen the video that I made hinting at this. But say Mr. Burrell is standing on top of Box Elder High School and drops the tennis ball to the ground. The school is about 30 feet tall. How long will it take for the tennis ball to hit the ground? So if I were to drop a tennis ball off the high school, which I did, then gravity is going to pull that tennis ball to the ground. So this right here is the function to model this situation. And this is real. This is like an actual equation modeling what gravity would do to this tennis ball. So h equals negative 16t squared plus 30, where t is the time in seconds that it's falling, and h is how high it is off the ground. Okay, so I want to know how long it takes for the tennis ball to hit the ground. So when the tennis ball hits the ground, how high is it off the ground? Well, 0 feet. It's on the ground. It's touching the ground. So h is 0. So 0 equals negative 16t squared plus 30. See that? 0 equals negative 16t squared plus 30. I'm trying to find what t would be when the height here is 0, when it hits the ground. Okay, well, here is a quadratic function that I can solve. I need to get my squared stuff on one side and everything else on the other side. So I'm going to go ahead and minus 30 on both sides. So I'll have negative 16t squared equals negative 30. Now I have negative 16 times t squared. Well, since negative 16 is being multiplied by t squared, I better divide by negative 16 on both sides. Negative 30 divided by negative 16 is 1.875. So I have 1.875 equals t squared. Now I have my t squared stuff by itself. I'm going to square root both sides. And when I do that, I get the square root of 1.875 is 1.369, or negative 1.369 seconds. That's how long it'll take for this tennis ball to hit the ground if I drop it off the school. So keep in mind, I have two solutions here. T equals 1.369 seconds and negative 1.369 seconds. Which of those makes the most sense regarding this problem? Probably the positive one. It's going to take almost 1.5 seconds. I'm not going back in time. It's not going to be negative 1.369 seconds. So in this case, this is the answer of my two solutions that makes sense. So if I were to go up on top of the high school right now, drop a tennis ball off the ceiling, it would take about 1.36 seconds to hit the ground. And this is the type of real-world problems that you'll see and that we'll continue to see that can be modeled and solved using quadratic functions. So we started off pretty straightforward, pretty basic. We're going to build off from here, but I hope that by the end of this video that you are able to do this. I hope you're able to solve a variety of quadratic equations using the square root method. All of these quadratic functions that you deal with today will have an x squared term and a number term. There will not be an x term in the middle anywhere. We'll start dealing with that in the next lesson. So hopefully today you can solve a quadratic equation using the square root method. I hope you enjoyed that. I hope you're starting to see some of the real-world scenarios you can model with quadratic functions. And I hope that it was beneficial. I do hope you enjoyed it as much as I did.